Okay, let's dive right into this explainer. Today, we're going to completely recontextualize the annoying everyday mosquito bite, because as you'll see, it is actually a highly sophisticated microscopic surgical strike. We are going to map out the complex mechanics behind these bites, and honestly, trust me on this, by the time we finish, you are never going to look at this tiny insect the same way again.
So if I asked you, what is the world's deadliest animal? You'd probably immediately think of apex predators, right? I mean, Hollywood has totally trained us to fear razor-sharp teeth, crushing jaws, massive claws. But the reality is going to surprise you. The true statistical heavyweight of the animal kingdom actually operates on a completely different, almost invisible scale.
Just look at how staggering these numbers are. While great white sharks claim around 70 lives globally each year, and lions are responsible for maybe 200, the tiny mosquito, it's responsible for a mind-blowing 1 million human deaths every single year. They are, absolutely, without question, the deadliest animals on Earth. But how exactly does an insect that literally weighs less than a raindrop rack up such a massive body count?
Well, that brings us to Section 1, tracking the target. Because to understand how they pull us off, we first need to figure out how they even find us in the first place.
Mosquitoes use this fascinating multisensory cascade to hunt. It's like a highly tuned radar system, and it actually starts with your breath. From up to 18 meters away, they can detect the tiny carbon dioxide plumes you exhale. As they fly upwind and get a bit closer, they switch to visual cues, looking for dark contrast against the horizon. And finally, as they zoom right in for the landing, they sense your body heat and the specific volatile chemicals produced by the unique bacteria living on your skin.
The really crucial takeaway here is that this tracking system is incredibly precise. And unfortunately, it heavily targets vulnerable populations simply based on their biological exhaust. For instance, because women in the later stages of pregnancy exhale about 21% more carbon dioxide per breath, their biological signature basically burns way brighter to a hunting mosquito. This effectively doubles the number of malaria-carrying insects attracted to them.
All right, moving into Section 2, Anatomy of a Bite. Let's get to the main event and see how the complex mechanics of the actual physical infiltration take center stage. So, the proboscis. To the naked eye, it might just look like a simple single needle sticking out of the mosquito's head, but it's actually an intricate housing for a complex 6-part toolkit. The outer sheath, which is called the labium, acts as this flexible protective casing. When the female mosquito lands on you, that sheath bends backward, getting out of the way, so the delicate, highly specialized instruments hidden inside can deploy directly into your skin.
Inside that hidden bundle, it's basically a microscopic surgical team. First, the mandibles pin your skin down, holding it tight. Then, the maxillae step in, acting literally like microscopic saws slicing through your flesh. Once they break through, the labrum, which is a flexible hollow tube, probes around inside your tissue until it successfully taps into a blood capillary. And at the exact same time, a secondary tube called the hypopharynx is actively injecting the mosquito's saliva straight into the wound. Now, remember those saw-toothed maxilla I just mentioned? They don't just push blindly through your skin. They actually vibrate at an incredible 30 hertz. So they're moving 30 times a second. This creates a cooperative mechanical vibration, essentially a microscopic jackhammer effect that slices through your epidermis so smoothly, it very often completely bypasses your nervous system's alarms. I absolutely love this detail because it just perfectly highlights the contrast here. You have these microscopic, near-painless mechanical tools, yet they leave behind massive macroscopic devastation. Human engineering hasn't even come close to replicating this kind of precision. Think about it. The amount of force the mosquito needs to puncture your skin is literally 1,000 times lower than what a doctor uses when they give you a vaccine. Which leads us right into Section 3, the saliva cocktail. Because once they've physically broken in, the mosquito needs a chemical getaway plan. They have to steal your blood without triggering your body's defenses. So the physical breach is really only half of the complex mechanics at play here. This is where the mosquito's chemical warfare really kicks into high gear. They inject over 100 different proteins just to bypass our hemostatic defenses and keep the blood flowing freely. They're using local anesthetics so you don't feel a thing. They drop vasodilators to force your blood vessels wide open. Then they deploy proteins like enephilin or aprase, which actively neutralize your blood's ability to clot or form platelet plugs. They are systematically, chemically dismantling your body's natural defense mechanisms in real time. So think back to your last itchy mosquito bite. You know that super annoying welt? Yeah, that wasn't the physical puncture you were feeling. That was actually your own body overreacting to the chemical weapons left behind. Long after the mosquito has secured her blood meal and flown away, your immune system is left to clean up this potent biochemical sabotage lingering in your tissue. And that results in that familiar, swollen, itchy welt. All right, Section 4, hijacking the system. Because as advanced as the mosquito's complex machinery is, it can actually be weaponized against the insect by even smaller invaders. And this is where the story of disease transmission truly begins. Now, it is absolutely vital to understand this next point. Mosquitoes don't naturally carry these deadly viruses. They only pick them up incidentally while taking a blood meal to secure protein for their eggs. The mosquito itself isn't inherently toxic. It's really just an evolutionary delivery vehicle, a vessel that pathogens have learned to use to travel from one human bloodstream to another. And turning a mosquito into a vector? It's a surprisingly grueling biological journey for the pathogen. But once they reach those salivary glands, they take complete control. The pathogen has to survive being digested in the gut. Then it replicates inside the insect's body over an incubation period of up to 23 days. Finally, it has to migrate all the way to the exact anatomical structure, the salivary glands, that will guarantee it gets ejected into the very next human host. You can actually see the real-time effects of this hijacking and how the insect behaves. The malaria parasite actively manipulates the insect to exponentially increase its own transmission rates. See, a healthy mosquito, it just wants to bite once, fill up on blood, and leave. But a mosquito infected with malaria exhibits this entirely different, totally frantic behavior, bouncing and probing from person to person. And here's how they do it. By destroying the mosquito's ability to use its own anti-clotting apparase, the malaria hijacker essentially forces the frantic insect to stab multiple people just to get a single tiny meal. Because the mosquito can no longer deploy the chemical it needs to stop the human's blood from clotting, her feeding gets constantly interrupted. Starving and completely desperate, the insect has no choice but to bite again and again and again, spreading the parasite to a brand new victim every single time. But wait, the manipulation doesn't even stop at the insect. The parasite literally changes how you, the human host, smell just to pull more of these biological syringes right to you. By altering your scent profile, the malaria parasite turns an already infected human into a glowing biological beacon. This basically guarantees that fresh, uninfected mosquitoes will come bite you, pick up the parasite, and continue this deadly, vicious cycle. So now that we've mapped out the insanely complex mechanics of this micro-heist, it really leaves you with one massive question. How will human engineering ever counter millions of years of evolutionary perfection? From 18-meter carbon dioxide tracking to 30 hertz vibrating microscopic saws to absolute biochemical sabotage, the mosquito is truly a terrifying marvel of nature's design. Thank you so much for joining me for this explainer, and as always, keep asking the big questions.